Welcome to the video on isotopes. Today's point of this video is for you to understand and see the difference between a mass number and the atomic weight also, because these are often confused by students. Alright, so first of all, what's an isotope? What does that mean? Okay, isotopes are atoms of the same element. Okay, if they're the same element, they have to have the same atomic number. Remember, atomic number is the identity of an element. Okay, but they have a different number of neutrons. Okay, so that is the big difference. All right, so we're going to use an example here. Go ahead and get everything up here. All right. The mass number for an element is, or for an isotope, is when we add up the number of protons, okay, plus the number of neutrons. All right, so most of the elements on the periodic table, they exist in two or more forms, meaning they have two or more isotopes. Okay, for example, chlorine, okay, no matter what, the atomic number, which is given the symbol Z here, okay, is 17. So we learned earlier the atomic number as a symbol of Z, and this 17 comes from the periodic table. Okay, so if you look at your periodic table, that's the atomic number. All right, the mass number can be different depending on the isotope. So chlorine exists as chlorine 35 and as chlorine 37. Sorry about that. Okay, so the mass number is equal to the number of protons plus the number of neutrons. So if you look here, this mass number, that's what that equals to. So you'll see an element written out this way and have a number in the superscript and a number in the subscript. Okay, the subscript number is the atomic number, and that number always comes from the periodic table. Okay, if you look over here to the right, we have chlorine 37. Okay, so these two are isotopes. Oops. Get my pen here. Okay, so what I want you to notice is isotopes are the same element. See here? So if they're the same element, they have to have the same atomic number, because if that changes, it's no longer chlorine. All right, the only difference here is a difference of two neutrons, okay? Chlorine 37 has two more neutrons than chlorine 35. Okay, so the number of protons in this isotope of chlorine is 17. That is the identity of chlorine. Okay, the number of electrons, this is a neutral atom here, neutral element, and so it's going to also be 17. Okay, to get number of neutrons, so think about it, if you know the total from your mass number A, you know that the mass number is number of protons plus neutrons, then we can subtract. We can take 35 minus 17 to give us 18 neutrons. Okay, if you look over here for chlorine 37, we would take 37 minus 17 to give us 20. Okay, 20 neutrons. So the whole difference, if you look at your first definition, is isotopes are atoms of the same element. So there's chlorine, chlorine, same element, and they have a different number of neutrons. So if you look here, they have the same number of protons. They have to be chlorine. They have the same number of electrons, but if you subtract your mass number from number of protons, chlorine 35 has 18 neutrons and chlorine 37 has 20. So it has two more neutrons. All right. Students often get two terms confused. Mass number versus atomic weight. Okay, the mass number is what we just discussed. So that isotope was given to you. And a mass number is always a whole number. It's a whole number and not found on the periodic table. All right, so that's what we were looking at before. So this right here. Okay, a mass number is not found on the periodic table, and it's a whole number. So it's that specific isotope that you're looking for, that you would be given. Okay. Atomic weight, however, this is the weighted average of all the isotopes that naturally occur for a particular atom, and it reports it in atomic mass units. So this number, atomic weight, comes from the periodic table. Okay, this number is the atomic weight, not the mass number. Okay, so if I ask you what's the atomic weight of carbon, then you would look at your periodic table and you would say it is 12.01, and our units here are AMU. Okay, so that's the difference between the two. Okay, the mass number is looking at a specific isotope, where the atomic weight averages all of those isotopes and puts it on the periodic table. Okay, and these are going to be numbers that are, different periodic tables may use a different number of significant digits, but notice it's not a whole number. It's not exactly 12 here. Okay, it's 12.01. So we have our atomic number, our element symbol, followed by the atomic weight as our number underneath the symbol there. Okay, so how do we determine an atomic weight? This is just good to know, just to know how it got up there, and it's basically getting the average of the different weights of the different isotopes. So if we looked at chlorine again, okay, so we have chlorine 35. So its AMU is exactly 34.97, okay? And if you were to get the isotopic abundance of chlorine 35, 75.78% of chlorine is in the isotope of chlorine 35, or exists that way. 24.22% of it, okay, you'd have to be given these numbers. You're not expected to memorize or know these. Okay, exists as chlorine 37. So then you have an AMU of about 36.97. All right, so we pull these out of percentage, because percentage is always times 100. So I'm going to move my decimal back over and get these numbers here. Okay, and so now I'm just going to multiply, okay, that 34.97 by the percentage for each of those. Okay, so the numbers that we had on the previous slide. So here was our mass for chlorine 35, and then here's our percentage that we moved our decimal over, and this was for chlorine 37. And when you multiply, you get these two numbers here, and then you're going to add them up, and when you add them up, you get 35.4544. Since we had 4 sig figs in our problem, we report our answer to 4 sig figs. Okay, so finding the atomic weight of an element just includes taking the abundance of the mass of each isotope, and then you add them together. And so this number is the atomic weight and what's on the periodic table. So for all of the elements that have isotopes, this is what's done. It finds the abundance of that isotope, multiplies it times its mass, and then so forth for all the isotopes, and then you add them up to get the number that's on the periodic table. All right, so here's some practice. We're just going to practice looking at these mass numbers and elements. All right, so we have our element symbol here. This number, remember, is given the symbol A. So here's kind of our setup. E for element, A for mass number, and Z for atomic number, which is the number of protons. Okay? And what we're going to do is we are going to determine how many protons, electrons, and neutrons we have for the isotope that's given to us. So we're given the isotope carbon-12. 12 is the mass number. Okay, so mass number is equal to protons plus neutrons. All right, so we look at our number here and we see that we have an atomic number of 6. Okay, the atomic number is the number of protons, and it is also the number of electrons in a neutral atom, and this is neutral. Okay, to get neutrons, since mass number is protons and neutrons, we just subtract 12 minus 6 equals 6. All right, for calcium, protons, electrons, neutrons, it has 20 protons and 20 electrons. There's our atomic number, Z here. Okay, and you look on the periodic table, you would see that number as well. And then we have 48 as our mass number. So 48 minus 20 gives us 28 neutrons. Okay. And then for this one, whoops. Okay, we've got a atomic number of 79 here, which means we have 79 electrons. It's still neutral. Take 197 minus 79 and you get 118 neutrons. Okay, so these are examples of isotopes of an element. Okay, given the mass number, that's the whole number here, and looking at that and determining number of protons and neutrons in the nucleus and how many electrons would also be in the atom. All right, I hope this helps, and I'll see you next time.